Good morning. Good morning, folks. I think we've got the core folks just wrapping up now. Hopefully, everyone should be here soon.
Morning, Mark.
Hey, Casey, how are you?
Doing good. Thanks for all the feedback on the min-Alex size stuff.
Oh, yeah, no problem. I was thinking about it a little bit more this morning, and one advantage to the approach that you guys are proposing would be that you can just kind of dynamically increase the size by, adding new OSDs to that pool. So there is kind of a nice flexibility with that. If we wanted to do the same thing underneath the OSDs, we'd actually need BlueFS to be smart about like adding new devices or something.
Okay, I think that makes sense.
But yeah, still worried about like the total number of pools. But just given kind of some of the other things that it seems like maybe the feedback I've been hearing at least that we've been getting requests to dramatically increase the number of pools that can be created.
Yeah, I do agree. Um, some of the discussions have been about making each storage class have two different pools, which would would double it. But the suggestion that I had there was just one extra pool for the heads, which I think could be pretty much global um, to the zone.
Uh,
And it would be an optional one. So I think that would be reasonable.
Do you guys? I don't know what real people are doing. Do real customers or real users create like multiple RGW pools, or like is that is it usually just the default ones?
Um, so I know that index always goes on special special pools. For the data pools, I know that it's generally just between replicated and erasure coded. But we also have the idea of storage classes, and generally you have one pool that's faster media and one that's slower media, and those storage classes gives the clients a way to drive objects to one or the other.
Okay, okay. You don't have people like typically doing weird things though, where they're like having totally separate like groupings of pools for different RGW like setups or something crazy like that.
Well, RGW is zones, which is a primitive for multi-site. A zone is a set of pools, so each zone has its own.
Okay, okay. And how many zones will people make usually?
Um, Good question. I mean, in the normal multi-site configuration that's just for disaster recovery, it's usually just one zone per cluster, and you just have distinct clusters.
Okay,
But there are definitely newer use cases that treat zone as something that you can pop up several of, um, and that will definitely run into an issue with pool counts abused.
sure, sure.
So, what we suggest from our side usually is for performance reasons to have different pools per um, zone at least. Perhaps just distribute or just separate it for buckets where we need to have different index pools for performance. Um, what we have in addition, this is not a clear thing that we have only a single realm of a single zone group and zone, but we have perhaps multiple realms, multiple zone groups. This might be for performance reasons, this might be for logical structure permissions. So this is so having only a single zone per cluster, this is rather unnatural in our customer environments.
Yeah, the use of realms for isolation of different data sets is right. That's one of the design goals. If it's being shared on a single cluster, potentially you could share pools between the zones using namespaces of the pools instead of giving each zone its separate set of pools.
Yes, yes, it could. But the challenge sometimes with that is that you have different requirements, and then you need to separate those. So otherwise, we would go with the fastest requirement that you have and roll it out for everything. It might be not feasible for just highly structured environments where you have different needs. This is one of the things we see. The other thing is just even within a single pool, if you have the shared access from different buckets, so putting different indexes on this is not the best performance. So you could get better performance if you separate the pools per zones or buckets. So to have really just distinct pools created per zone or just whatever you use there in the structure. So usually we see that customers create large buckets, so single buckets with billions of objects, but those perform rather good. And separating the data across different buckets is one thing to get just better performance distribution if those buckets use different pools. So otherwise, you have only the structure into the buckets, and you can separate the index, lower the objects per bucket, but this gives you half the mileage only.
So when you have buckets that are that full, you just to make sure I understand, you only see a performance advantage by breaking it across multiple different buckets if those buckets are individually on separate pools?
It's not the only no, just you had a better performance if you then in addition use different pools for whatever reason.
Yeah, that's. I'm trying to think of why that would be the case. I'm not really coming up with. Is more PGs in that case, or the same number of PGs?
Then you have more PGs involved automatically.
Okay, so this.
Automatically, you could reduce the number per a pool there in this case, but this is not what we do. Yeah, usually we go
Okay.
with the same amount and then create so this way more PGs.
Hmm. I mean, there are some limitations if you have tons and tons of OSCs. Maybe presumably you'd see better parallelism if you had more pools with more PGs, spreading data around better. But how big of installation is this?
I cannot say exactly what size it is. This, I guess, currently 250 terabytes or so. So it's a medium size one, or not small one, but not even just any bigger one.
Sure. Even roughly, do you know the number of OSDs? If not, that's okay too.
I need to look it up. Yeah.
Okay. Um, yeah, that's interesting. All right. Well, I think we've got everybody from core in, so I'll quickly just dive into the pull requests here and get them over with. Then we can figure out. I think there might be a couple things to talk about. Okay. The only new one I've got on my list is one from Kifu that is changing the RocksDB cache to work with an update for RocksDB. I need to review that, but that's on my to-do list, hopefully soon. Closed, bunch of random stuff here. There's one from Igor here working on this incremental file metadata updates. I think that's just closed in favor of Adam's version. Let's see. Oh, the one from Booth for the CMake build type. That merged. That's fine. That was just you have a fix for a regression that was introduced. The make deferred writes less aggressive for large writes from Igor. That also incorporates a fix from Adam and kind of supersedes the stuff I was doing, which is good. It's a better fix. So that merged in last week. That's really good. That fixes an issue that we have in Pacific already. That's really good. Then there was Adam's one that got incorporated into Igor's fix. This finisher, give up the CPU automatically, that just got closed. I don't think there was much additional discussion on that one. Yeah, Patrick was looking at that, and so was Kifu. Yeah, I don't know. Anyway, moving on. Updated PRs this week. W tracing. Tipica is reviewing that now. More review, I guess, of this OSD compression bypass. Looks like Casey's been on that, continuing to review it. Oh, and then my RGW cache sharding PR. Thank you, Casey, for taking a look at it. I wanted to ask you though, what do you think about the locking? We talked about it a little bit last week, but I didn't have a good response ready off the cuff. But what did you think of it?
Well, there's two different commits that are kind of independent there. Are you talking about the shared lock one or the lock sharding one?
My cache sharding PR, the portion of it where I'm changing the mutexes from the shared mutex to just a normal simple one.
Yeah. I mean, I buy that.
Okay.
But I would just like to see some numbers if possible.
Yeah. I don't know if it makes sense to do it until we fix those other PRs though that were causing the regression.
Okay. I think these are things that came from downstream, and I haven't haven't kept up with those, so I'm not sure exactly what the issues are.
Yeah, there was. I think one of them was. I mean, it's all in the upstream code, right? When you say coming from downstream, what do you mean by that?
Uh, was it identified by the workload DFG?
No, this was when I was trying to test that caching PR. I ended up uh, basically having seeing this regression and ended up doing a bisect of master and ended up identifying what they were. This is the spreadsheet here, but basically this is what I was seeing when I was going through and doing a bisection. So you're right. This was, I think, maybe downstream did originally see like massive CPU usage increase, but then that led to why I ended up looking at cache sharding there and then all this stuff.
Okay, so you identified two PRs, and I think
It looks like it.
one of them I think was the stack allocator for the Beast front end.
Yeah, that one I couldn't revert easily because it's so much is dependent on it now. But the other one, that 35355, that one was fairly easy to revert and seemed to bring it performance back to the way it was before. That's this request timeout for Beast.
Okay, interesting.
Yeah, I mean it was really dramatic. I think somebody was going to look at it on the RGW team. I don't remember who now, or if anything happened from it.
Yeah, I don't know. This is kind of the first I've seen of this.
Oh, really? Okay. Yeah, let me see if I can uh, find out who it was that was going to take a look. Might take a little while to find the old messages, but yeah. In any event, I think that would probably eliminate a lot of the problem, even just figuring out how to fix the second one. Or revert it. I don't know, whatever you guys prefer. Um, so yeah, once we can figure that out, or even if you give me the go ahead just to like run with it reverted, I mean maybe we could try testing the cache then, but it's kind of not worthwhile to do it when it's things are kind of in such a rough shape with those PRs kind of in place.
Okay. Well, we were discussing your cache locking PR, Mark Kogan and I, and he wanted to do some experiments on it. So I'll make sure that he's aware of these other ones. Um,
Okay, cool.
Maybe he can make progress there.
Yeah, and I can split it up so that we're breaking the locking and the mutex exchange and the sharding out because I don't think they're really dependent on each other. I include them together because it seemed kind of like they were kind of complementary in a way. Um, in that my hope was that it wouldn't there wouldn't be as much benefit from the shared mutex with the sharding, but then it would reduce the overhead of locking and unlocking, which would remain constant even with shards. That was why I kind of grouped them together, but we could pull them apart. There's no reason they need to be.
Yeah, Mark Kogan said that when he ran initial tests on this PR, he didn't see much benefit. So
Yeah,
it could be that one is masking the benefit of the other.
it's quite possible that there isn't a significant benefit. Honestly, that's when I was trying to tease out to see if there was one, that was when I ended up going down this whole like rabbit hole of bisecting master and finding these other PRs that were causing problems. So it could be that this is
So,
all like not that big of a deal.
well, it could also depend heavily on the total number of threads running. Was your benchmark just with the default, which I think is 512?
I think this if you look at that spreadsheet, there's like all of these tabs where I was like changing stuff all over the place, and uh, it was all a little crazy. Um, see, now I gotta find.
Okay, I was only looking at the last tab. I see that
Yeah,
the other ones. Okay.
yeah. So obviously there's like a bunch of data missing from here, but that was the road I was going down when I was trying to test this thing before I ended up like getting sidetracked on the other stuff. But yeah, it's quite possible that in the long run this actually doesn't matter that much. Like the majority of the issue that I was trying to fix might have been um, like you know not cache, even though it looked like it was maybe cache initially. Um, I mean, there seemed to be some evidence of contention when I was doing like wall clock profiling on RGW. So, I mean, there might still be some, but it's a little fuzzy. I think getting things into good shape, or at least back into the shape they were before, and then trying it again might be the way to go.
Yeah, it sounds like we really need to focus on these two regressions in the Beast front end.
Yeah, yeah. I think my thing can just sit there. It's not that big of a deal to just let it wait. Um, but the other stuff is definitely the bigger thing to tackle.
Yeah. Um, Also, a lot of your testing um, is with shard counts less than 512, but I mean, we have some notable customers that are running with a lot more than that, and
Okay,
with larger thread counts, I would expect the contention to be a lot higher there.
sure, sure. Cool. Well, yeah, and I'm excited to hear if Mark Hogan sees anything interesting. He's really good at a lot of this, so he knows RGW very well. So that's exciting. All right.
Yeah, and I'll make sure that we create some tracker issues around the Beast front end regressions.
Cool. Yeah, I didn't because I wish I could find the chat window, but I thought someone on your team was going to work on this, but it's possible they got sidetracked with other stuff. There's lots to do.
Yeah.
All right, cool. So let's see. I don't think there's a whole lot of other stuff in the no movement other than that. With the RocksDB cache changes that Kifu had mentioned or had made to fix it, that makes me think that I need to get the. Well, it just reminds me I need to get the age binning stuff in still, and maybe this is a good time to do it since we're going to be mucking around in the our version of the RocksDB LRU cache anyway. So that's on my list as well. That's about it for this stuff. Anything I missed, guys?
Hi, Mark. I think one more PR is a bit important. It's old Igor's PR about splitting conversion of OMAP into smaller RocksDB transactions. Without it, we tend to have various problems with BlueFS and RocksDB converting huge amount of OMAPs.
Okay. I'm going to add the performance label to this one. And then I'll put it in. Let's see, has this been updated for a while or recently? Oh, yes, it has.
Yes, it's very recently updated.
Oh, yeah. Okay. I see. There you are. You reviewed it. That's excellent, Adam.
And I think about it because I want very much ported it to Pacific.
All right, I got it in our pad now. Okay, so let's see. Okay, Igor, it looks like you've been responding in that as well and updating things maybe too.
Yeah, it looks like it's ready for creation.
Okay, and then you split that into two separate PRs, is that right?
Into three pairs.
Oh.
There was a lot of valuable stuff with different scopes of back portability, so it had to be split.
Just double checking, Adam and Igor. So we want to backport 39377 entirely for the next point release, specific point release, right?
I want to backport it, yes. I mean, it's not even merged yet, but it should go.
Yeah, we have time. Okay, so this is the entire. There's no other. I see a split of 42832 and 42831. Those are separate.
Those are separate. They are not valuable, but not critically important.
Got it. Thanks.
All right, cool. Well, then I think we're all done with PRs. Okay. Are we, Casey? Are we done? Do you think on the topic of the RGW proposal for the QLC drives, or now that we have more folks, was there anything that you wanted to bring up regarding that?
I think there's been good discussion on the mailing list, and if I would want to make sure that the folks from Intel were here if we were going to continue discussion. They've been coming to the RGW refactoring call, but I will invite them to come here next week, if that's all right.
Yeah, absolutely. That'd be great. Do you know if any of those folks are on the OpenCast team?
I don't think so. Anthony, who replied on that thread, is the one that we've been working with primarily.
Sure. So there's been separate conversations going on with the Intel folks that work on OpenCast because they've obviously open sourced it now as OpenCast, and we've been trying to work with them to get it into shape where they might be able to submit it to the upstream kernel. But I think right now it's not quite there yet. But potentially, if that's done, that would maybe be another option as a way to approach this. It might be good to at least have them there to provide feedback.
Yeah, agreed.
I do think one way or another, this is something that we're going to have to deal with in the OSD on some level, regardless of what you guys end up doing. If you want to try to piggyback on that or do the separate pool idea, I do think we're going to have to figure out how to deal with these kinds of drives.
Yeah, that's been my intuition as well. I think this does probably belong in the Rados layer, but if separate pools are kind of the only way to do that, then that definitely brings it up into RGW.
Adam and Igor, what would you guys think about being able to place objects on the fast device based on some hint or object size or something?
So we are now talking on Rados extension now, yes?
If let's
additional
ignore
hint to existing objects.
or maybe you just say that you want objects that are small to be put on fast device. But some way we figure out a way that we decide that we would use some portion of the fast device instead of always for only RocksDB levels, potentially for objects as well that are small.
Well, I recall we had an attempt to keep small objects in RocksDB itself. But finally we refused to go this way. I don't remember the reasons. As for keeping objects at places directly, I'm afraid it might be inappropriate for keeping tons of files.
Sorry, what was that, Igor?
Well, I'm afraid BlueFS is not designed good enough to keep tons of files in it. And that's what we might need for if we decide to keep small objects there directly.
What would be the problem?
Well, all these data structures like reading all file list into memory, lack of directory structures, things like that.
Okay. So the alternative would be that when I talked to the OpenCast guys at Intel, and maybe DMCache can do this too, I don't know. It sounds like they maybe have the ability to, when they put OpenCast in front of a block device, to pin a region for staying on the fast device behind OpenCast. So maybe the first I don't know, maybe 20 gigabytes or something. It's probably definable. Would You could put things there and they would stay pinned on the fast device, and then the rest of your device they would use for cache to float things in and out of the fast device, and potentially be demoted back to the slow device. Potentially we could use something like that to accomplish this as well.
But I still don't understand who decides which files to put at this fast partition and how they are kept there.
I probably am.
What file system will be there?
Oh, with this, then it would have to be BlueFS would have to know that it would need to write these to a certain region, right?
BlueFS?
So right now, with the way the allocation works, you look for some region, right, that you're going to write into for space.
Okay.
Instead
you mean in BlueFS or in BlueStore itself? So
I don't remember
because
which one looked.
I imagine the solution would need to somehow target the allocator that will get extra info whether the block should go to a fast device or slow is acceptable. Then allocator would provide new area, and maybe that way we could keep it. Only connection then would be BlueStore code would be augmented with some retrieval of fast slow hint, and depending on that will trigger allocator.
Yep.
Sorry, Adam. Sorry for interruption. You mean at BlueStore level we like to try to use different devices, slow one as we do for now, and the fast one, part of the fast device which is used for RocksDB.
I'm not stating that. I'm inventing this as it goes to try to adapt to solution when one device that is presented through block device interface has some regions that are fast and some regions that are mapped to some slow device. Whatever it's being done on the actual device level or some conglomerate level. And I'm now thinking, how could we, if such architecture is presented, how can we adapt BlueStore to utilize it?
And what I want to point out too is not necessarily always about fast and slow, but in this case, it's about like huge QLC flash devices that have 64K allocation strategies. And if we do 64K min-alloc size to match it, then we're back to having the same space amplification problem that we used to have before Igor's excellent work. So the idea is if you have a small object come in, then you can put it on the device that has a small allocation strategy.
Okay, that is very difficult. I mean, you would like to have on the same device different block sizes for different tasks.
But that can be, we don't necessarily need to worry about that because that can be underneath us, right? If you're never putting anything smaller than 64K on these QLC things, and if it's all aligned properly, then you could still have a 4K min alloc size at Blue Store layer. You'd not have to worry about it because you'd never be putting things that are smaller than that on these QLC devices.
But then we introduce another problem, just we don't know what the real object size that we get will look like, and then we just perhaps run quickly out of space for the small ones while having tons of on the QLC device capacity left. And we
Yes,
cannot correct that.
that's where the pool idea is better in some ways, right?
Yeah,
The one that Casey presented.
Yeah, so just a quick comment on the idea to put this in RuxDB. We had some weeks, a months discussion about getting rid of RuxDB eventually, perhaps. And when we just would go this way there, and then we nail it down to RuxDB forever, pretty much. Yeah, that would.
I don't. No. I don't. Yeah, let's not put this in RocksDB. Let's not put these things in RocksDB. I agree. I think we made the right decision not to do that. What I'm talking about though is have the allocator, as Adam said, be able to say, well, I have some space on this device, I have some space on this device. I have an object coming in that's got a hint saying that this is small, it's going to remain small. Like for these objects that they're talking about for RGW. And therefore, I want the allocator to find and put this in some region on the fast device, and by fast device in this case is actually a device that can handle small allocation sizes under the hood. But if it's going to be a big chunk of data, then I'm going to put it over on this other thing.
So, well, I think this problem should be split into two parts. The first one is to use two different or multiple devices under Blue Store, similarly like we have in BlueFS right now. So this is doable, maybe not that trivial. And the second part is to merge multiple small objects, like 4K object or even smaller, into a single 64K block and write that to these QLC devices. They are pretty independent, I think. And well, both are not very simple, say.
So I don't know if you saw it, Igor, but the alternative route that they're considering going is far simpler from our perspective, where they would just have multiple pools and they would store the data that they know is going to be small. These small objects for RGW would go in the pool that's backed by these Optane or whatever devices. And then the bulk big data would go into the pool that's backed by a QLC. I don't know if that's good enough. Maybe.
I mean, making it on that architecture level, in deployment level, is preferable, because if we implement this on Blue Store level, then we have to tackle all that issues, as Igor mentioned, that we are changing a size for small writes. We split a block that the object that previously had been continuously written, and by some hints it was a large one, and then we are overwriting parts of it with small writes. And there are a lot of decisions to take regarding how to handle such situations. RGW is easy because I expect there will be no overrides in the middle, just single write objects.
But the question is how to, well, in RGW you get the file name, and then you have to decide which pool to go to retrieve this object from.
Yeah, it's
So that's
multi.
doable. We will have a sort of hint on write, but we don't have one during reading. It might be not that efficient, and you should to pull both
True.
pools.
I forgot about that. So splitting in pools. Now I don't even think it's feasible.
Well, from the design point of view, the approach when BlueStore supports efficient ways to keep both small and large files is preferred to me. But well, it's definitely not a simple task. But well, how to say, it's more consistent or more elegant, more transparent to users.
Yeah, I can agree with Igor that we possibly should implement extend BlueStore with ability to have varying allocation sizes inside BlueStore and handle maybe files that way, or any other way to handle small objects also efficiently with small write amplification.
I've wanted for a long time, this is kind of like a dream, but to be able to have BlueStore handle pools of devices that have different characteristics, and then have it make better decisions about where to place data based on the characteristics of the devices that it manages.
And well, actually, that's what BlueFS does in a sort of way. So, and well, that's definitely doable.
So Igor, right now, like how generic is the code that we use for moving the RocksDB SST data back and forth across the fast device and the slow device? Is that something that we can extend, or is it all very
I doubt we can reuse it in BlueStore, but it's not very complex. So it's just multiple allocators, and depending on some hints you choose. Well, so you need multiple allocators. You need some hints to select which device to use, and which is more complicated is that you need data format changes, since you need to include when you persist your metadata, or the persist allocation metadata, you'll need to specify which device is to be used. So this, well, again, that's doable, but it would need pretty significant changes to metadata format. it definitely wouldn't be compatible after that.
Once we will have such a mechanism in place, when we get more objects than we have space left. So what we want to do in this case then, and how we could distinguish between those pinned objects and whether they are viable still to live on this fast device versus just get drained out like in caching mode. Which is,
well,
yeah.
I think there are two options here, and we can probably have some policies on that. But the first one is to refuse writing when you have lack of space at the specific device. And the second one, as similarly as we have in BlueFS, is to spill over data to slower devices if faster ones are unable to fit the data.
And I mean, theoretically, that should work fine. You just eat the space amplification penalty, right?
Yeah.
Maybe a speed penalty too, because I don't think these QLC drives are particularly fast at, lots of small random reads or something.
Well, at least we have some similar methods in BlueFS, so more or less it's clear what we should have and how to handle that. The second part is more scary to me, since it requires some pretty significant metadata changes to maintain multiple objects within a single disk block. And we've never had something like that. And,
do we need to do it, Igor? Like, do we need to actually do that if
we need that because we are talking about 64K optimal block size for QLC drives, and we are talking about small files, small objects, which should be much less than the 64K block, as far as I understand.
What if for these QLC devices, though, you always paired them with a different device that can handle the small objects?
So you mean small objects are not kept at QLC devices, but...
Yeah, exactly.
If you would go for just a fully occupied fast device space, and your cluster is nearly full, and then you start to spill over heavily on those QLC devices, you might have a different problem than that you need to handle in the wild. You see then quickly getting up a capacity that is not seen before, just you cannot react perhaps quickly enough.
Yeah.
Yeah, and that's a sort of issues we observed with BlueFS. So these well-known spillover cases. Choosing optimal size for fast devices. And things like that. Then one needs means to recover after such spillovers and to migrate.
It's kind of an...
Yeah.
Sorry. Go ahead, Igor.
Yeah, that's all I want to say.
It's kind of an inherent problem to these, right? These devices is that they want a big allocation size, and if you have lots of small data, small objects, then either you're going to need to figure out a way to like mangle them into the same 64K chunk, or you need to like eat a lot of space to just put them into one allocation unit. I mean that's going to be inherent no matter what we do, right?
Sorry, say it again, please.
Your choice with these devices, if you have a 64K allocation size on it, either you're going to spend a lot of extra work trying to mangle and put lots of little objects into one chunk to store on the device, or you're going to waste lots of space writing these out to the device. It's just kind of an inherent limitation of these devices, right?
Yeah, looks like that.
So I mean, no matter what we do, I think we're going to deal with this one way or another. I don't think there's any easy solution for it. Except maybe the only easy solution is to not put small data on it.
Yes, but I don't think that's a very wise solution, because as Matthias pointed out, we would definitely see some threshold when we start to spill over to large block device, and then that space may get eaten very quick, and there will be a lot of problems regarding that. So possibly we would need to teach BlueStore how to reuse the same allocation unit for different objects, as Igor mentioned before.
Well, I mean, Adam, the alternative, right, is that you could say you've run out of space for small objects when you filled up the fast device.
Oh, and just reject writes.
Yep.
Okay.
Well, what's about another alternative, which is to make RGW to pack small objects into larger ones and deal with that on its own. It would probably has some impact on the performance, since you need to, when you put some small object, you need to read. Never mind.
I don't think that's a good idea. Yeah. I mean, it's offloading problem to RGW guys and not really giving back in return.
I think at that point you offload it into the application and tell them that this is designed for big object storage, so don't write small objects.
Okay, great.
So today we have those QSC devices. Is there anything, just we had the change for the HDD in the past for the allocation size. So what do we expect in the future? So how the devices, so specialized hardware or new hardware coming up, would it be viable to look into just merging smaller objects into bigger allocation sizes, just in a way looking forward into the future? So whoever comes up with new ideas from hardware vendors.
It sounds like a good area of research to me, but if it were my decision, I'd say that we do the simple thing starting out and just reject writes when it's full, and then someday in the future, after lots of research and experimentation, maybe you try to do Igor's second idea to do this merging.
Yeah, so to have block write is something that I really wanted to avoid. So just then I would rather the amplification capacity and then the rest of running quickly out of space instead of having blocked writes for
Okay.
no real reason to see for the user.
It's the same problem.
Well, I think that's actually depends on the use cases. So if that's primary for backup purposes, then these performance penalties are not that important. But if that's some live system, then you care more about performance and not much about the space amplification. So I believe there are no general solutions here. So both might be useful, and that's a matter of access pattern in this case.
We still have the exact same problem with the original idea with pools, though, right? If you have a separate pool for small objects and a separate pool for large ones, and your small pool fills up, you're gonna have to block writes anyway, right? You do that at the RGW layer.
Yes, but at least now we have ability to monitor how much that pool is filled on admin level. But if we hide it in BlueStore, that information will no longer be so easily available.
Do we not expose that? I thought we did now. Maybe I'm wrong.
If we split into two kinds of devices, two domains, then we will have to export that extra split. But if it's in a pool, then you just list how pool is filled and you get it right away.
Adam, but I thought that we did now export how full the fast device in BlueStore is. Maybe I'm wrong though.
Yes, we can read that, but that's a fast device in BlueFS. It's only used for BlueFS. BlueStore block device does not use it.
Yeah, I agree. I thought that got exposed out through like the JSON interface to the dashboard. Maybe I'm wrong.
Yes, it is, but I mean, if you want to reuse that device for a side channel for small objects, then you can read it. That's true. If that's your intention, but I wasn't thinking it that way. I was more thinking that BlueStore block device is being expanded by something else, not that BlueFS and block device have to share that special device, because that
Sure.
device is also different characteristics. We don't care for small block for BlueFS, but we just care for it being fast.
Yeah. Yeah, in this case, we'd almost be changing it a little bit. Right now, it's that it has a characteristic that it's not only fast, but it has the characteristic that it's also has small allocation units, so it's desirable to use for different purposes.
Yeah, of course, correct.
Yeah.
And well, honestly, at this point, I can say that I dislike the idea to keep this small data at RocksDB level. It might have some benefits as well, and it's not that complex. So maybe.
Yes, I remember I didn't like keeping small objects in RocksDB, but now when I think about alternatives, it doesn't sound so bad.
Oh, no. Don't do it.
Okay, at least please do not throw that away completely. Maybe
I
let's not get that. You know.
I would be happy to test solutions if you want to try again.
Yeah. Okay. Sorry, folks. I need to go. Let's proceed next time.
Yeah, it's we're past the hour anyway, so nice talking to you guys. Really good discussion.
Yeah, thank you, Mark. I think we should go back to that topic in the future because it doesn't seem to go away.
I know. Yeah, I think it's gonna get worse too. All right. Have a great day, everyone.
Yeah. Thanks. Bye.
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 Yeah, see you.